record. Okay, can everybody go to their notes booklet? And we're going to talk about fuel economy. So obviously, we need a way to compare vehicles in terms of how much fuel they consume. Now, for the overwhelming majority of vehicles we're going to talk about, fuel is good old regular gasoline. But of course, we realize now that there's electric vehicles, there's vehicles that don't run on regular gas, they run on diesel or whatever. So we'll talk about that, but for the most part, fuel economy is talking about how much gasoline you consume and at what rate. So we have to compare all vehicles fairly. So the way that they do this in the car industry, the automobile industry, is they define fuel economy as, and here's where we'll start our notes here, guys, the rate at which a vehicle consumes fuel, and again, notice we're using the word fuel, not gasoline, so we can compare other types of vehicles besides gas-powered vehicles a little later. And it's expressed, and I just misspelled expressed. Ugh, need more coffee. Expressed as a ratio of L divided by 100 kilometers. And this, of course, means liters of fuel consumed. And 100 kilometers is literally per every 100 kilometers driven. Per every 100 kilometers you drive. This number, this ratio number, is always printed on one of the stickers that'll be on one of the windows or the windshield of a brand new vehicle. In fact, it is the law that every appliance you buy that consumes a significant amount of electricity or fuel, whatever it runs on, if it's consuming energy, the Canadian Department of Energy and Natural Resources has made it law that it has to have a sticker on it. You've probably seen stickers like this. You've maybe talked about stickers like this in other courses, like for example in grade 9 or 10 science. When you're talking about energy consumption, you might have looked at a sticker like this. You'll find stickers like this on washing machines, dryers, refrigerators, freezers. Anything that consumes a significant amount of energy, you have to, by law, when you buy it new, the manufacturer has to put one of these stickers on it. If you're going, hey, well, I just bought a computer the other day that didn't have one of these stickers on it. Yeah, small electrical appliances that don't use that much power, they don't fall under this law. It has to be something that consumes a significant amount of power. A good example is a fridge. You've all probably seen those or heard those commercials where they try, Manitoba Hydro tries to convince you to turn in your old fridge. It'll be, hey, you got one of those old fridges in your basement that is only holding, a few leftovers nobody's going to eat and then you'll throw out, and maybe, beer in case family comes over to visit. Well, think about retiring that fridge. They'll even save you the hassle of having to take it to the dump yourself. They'll come and pick it up. Why are they trying to encourage you to get rid of a perfectly good working appliance? Because it's costing you, and of course the world, energy that you probably don't need to consume. Probably costs you $200 a year to run a second fridge. Is it worth it? Again, what's sitting in that extra fridge? Well, if you're like me and you have a big family, I have 3 grown men that still live in my house, my 3 grown children. So yeah, we tend to use the secondary fridge every day. But if it's just, my mom still has her second fridge. She lives in the house by herself. It's like, Mom, let's get rid of this fridge. It's just sitting there, It's like, well, I have some leftovers in it. You're just going to end up throwing them out. But anyway, Canada is trying its very best to comply with energy-saving techniques and energy-saving, protocols. We did sign the Paris Agreement. We are trying to reduce our carbon footprint. So we're trying to convince people that it's a good idea to get rid of a second fridge, a second freezer, things that consume power. So how much it costs you to run something for a year is always on the sticker. So now when it comes to a car, here's my fuel economy number right here. And notice it's the average. This is kind of blurry. That made it larger, but no less blurry. Sorry about that. It's the actual average of these two numbers. Because, and this is counterintuitive to people, you actually consume fuel at a faster rate, at a higher rate in the city, that's a city, and in French, ville, versus on the highway, or en français, route. And that seems counterintuitive, but I'm on the highway. I'm stepping on the gas pedal and going faster. Shouldn't I be using gas, like burning gas at a faster rate? How am I getting better fuel economy on the highway than I am in the city? Well, because vehicles are actually designed, cars are designed for the engines to run at constant rates. And they work the most efficiently that way. In the city, what are you doing? You're speeding up, slowing down, stopping. Speeding up, slowing down, stopping. And that acceleration that you're constantly doing burns a lot more fuel than setting your vehicle at a constant speed and then just driving. Right on the highway, you don't have to speed up and slow down as much. And you have, of course, a mechanical electronic device in your vehicle that, assuming the road's nice and quiet, sets your cruise control, and you don't have to touch that gas pedal at all, right? If you're a lead foot, that means that you step on the gas a little too much, and you always ride the gas pedal even when you're on the highway and no one's around you. You're wasting fuel. You're burning it. You know, it's like, oh, I notice I'm going over the speed limit. Then you take your foot off the gas. And then, oh, now I'm going too slow. Then you put your foot back on the gas. You're completely wasting fuel. Set your cruise control, and you can totally maximize this number here. Anyway, you'll notice that this number here is, again, an average of city driving and highway driving. And when I look at this, this does kind of weird me out a little bit, because I know it's an average. And how do you find an average? You add up the two numbers and divide by 2, right? Okay, 10.7 and 7.4 is 18.1. 18.1 divided by 2 is 9.05. Shouldn't that round to 9.1? But for some reason, I guess they're allowed to say, well, it's a 0, so it's 9.0. I'm sorry, but I would, if this was a test, I'm taking out my red pen and I'm giving that an R for rounding error. But I guess a manufacturer gets to get away with that, because obviously the lower this number is, the more attractive this vehicle is to buy. This is, of course, a sticker that the government says they have to put on the car. But it is a sticker that goes on the car, and you're walking around in the new car shop and, ooh, look at how good the fuel economy is on this one. And they rounded wrong, but okay, I guess they can get away with that. Taking advantage of the fact that they think that we can't round numbers, I guess. Anyway, the other big important number, well, there's actually a couple other numbers on here that are interesting. It's carbon dioxide rating, right? How much it emits, the emissions that come out of it. Again, it's how much it contributes to the smog in your city that you're driving in. We have committed as a government to try to reduce these numbers as much as possible. We could do more. Many countries in Europe have now just decided that they are going to no longer license and register new gas-powered vehicles starting, I think, in 2022 or 2023, which is just another year away. So that's it. Not every European country. It's going to be tough to convince the Germans to give up their gas-powered cars. But quite a few European countries are just saying, that's it. We're going to phase out gas-powered vehicles. Because you know what the carbon dioxide and the smog ratings are in electric vehicles? How about 0? Or very close to it. So that would be much better for the environment. Anyway, getting back to the numbers that getting back to the numbers that we care about. This number here is just the American version of this. Instead of liters per 100 kilometer, it is miles per every gallon. I think that's what that says, miles per gallon. So you get 31 miles per every gallon. If you did a little bit of math, you could convert this number to that number just using some unit rates. This is the other interesting number I wanted to talk about for a sec. This is what they assume this vehicle is going to cost you to drive every year. Now, it looks to me like they're basing that on 25,000 kilometers of driving. Some of these Now this is interesting because I think most stickers actually base it on 20,000. The average, I can't seem to make this erase now. Oh well. The average driver tends to, according to the government, drive 20,000 kilometers per year. Now, obviously, some people, it's an average. Some people drive more, some people drive less, right? Some people buy their car, and it's that little old lady that just goes and gets groceries and drives to church on Sunday. She's not going to get anywhere near 20,000 kilometers of driving in a year. I, on the other hand, commute all the way from the west end of the city, and I drop my wife off in St. Vital before I come here. So every day, 5 days a week for, 200 days of the year or whatever. No, not quite that many. There's only about 100 school days in a year. But whatever, it's still going to end up being way more than 20,000 kilometers. I put on more than that. So keep this number in mind, though. When they give you here's what this vehicle costs to run you, to run for a year, they're usually based on 20,000, although this one seems to be 25, which is interesting. Okay, let's do some math. Example 1. First of all, let's just figure out how to calculate how much a single tank of gas costs us. A car requires 52 liters of gas to fill the tank. The cost of gasoline is 121.9 cents per liter. Yeah, remember that the sign at the gas station isn't in dollars, right? What is it today? I think today it's 126.7 or 127.9. Is it 129.7? Okay, so let's say it's 129.7. That's a lot. So that is, of course, cents per every liter that you buy. Okay, so that's what it is. So this is actually a little cheaper than our gas is right now. But let's use this number. So 52 liters. And okay, the big question in all of math. I'm doing a word problem. Am I timesing or dividing? I always break this down in my head to the question, is it an of or a gazinta? And I'll tell you the story behind that. When I was in grade 3, I grew up in Transcona, of course, and all of my elementary teachers tended to be women from old country, Ukrainians. And Transcona was a very Ukrainian part of town when I was a kid. To the point where my school had 2 classes for each grade. It was a small school. 2 classes for each grade, 2 grade 1 classes, 2 grade 2 classes, 2 grade 3 classes. And when we hit grade 3, that's when you were supposed to start taking French. But in my neighborhood, there were so many Ukrainian families that you could choose not to put your kids in French class. They could take Ukrainian class. So being not Ukrainian made me an ethnic minority in my school. And in my grade 3 class, there was only, I think, 4 of us out of 2 classes of like 30 kids. There was only 4 of us who were not doing Ukrainian. So my French class in grade 3 was 4 kids, me being one of them. That's how Ukrainian Transcona used to be when I was a kid. So, of course, my teacher, Ukrainian, she would explain to me, this is 6 divide 3, and you say, this is how many 3 gazinta 6? And so I thought for years that gazinta was a word, because she was saying how many 3 goes into 6, right? And I go, oh, 3, 6. I just count by 3s, and then the answer is 2, right? Because 2 goes into 6 3 times. So that's the way I've always thought of divide. So when I think of a problem and I think, okay, I have to deal with this number and this number, am I timesing them or dividing them? I ask myself, is it an of or a gazinta? Do I want this many of this, or do I want one of them to go into the other, goes into? And in this case, it's an of. Now, there's another way. There's a more grown-up high school way to figure out this. And you could, again, this relates to something I mentioned a minute ago. Unit rate, unit ratio. Look at the units. I wrote down, I put the L on there for a reason. I need to cancel the L. So doesn't the L have to be on the bottom? 121.9 cents per every 1 liter. So the liter on top, liter on the bottom. That's how I know it's a multiply. If I needed the liters to stay on top, the way I need the cents, I need the dollars to stay on top, I would have had a divide because this top number has to end up on top. So there we go. It's actually a multiply. And I already did the calculation on this. And I got 6338.8. But of course, that's cents. I don't want to know how many cents it is. So once again, here's the question. Am I timesing by 100 or dividing by 100? Well, in my world, I use unit rates and I always times. but I'm timesing by the fact that there is $1 per every 100 cents. So I'm dividing. How many hundreds goes into this? So cents cancels cents, and I'm left with dollars. So divide this number by 100. It should be easy. You shouldn't need a calculator to divide number by 100. You just move the decimal over twice. And the dollar sign stays with the number. Usually we put it in front. And it's money. I can't tell you 0.388 cents. There we go. Round to 2 decimal places when it's money. So there we go. There's a very typical type of easy question. How much does a tank of gas cost you when the price they give you is like the price on the sign in cents? And, you know, they always, you should know, or you can look and see how much it costs to fill up a tank of gas, right? Your average gas tank on most vehicles is either 55 or 60 liters. So anyway, there's example 1. Example 2, let's deal with distances. Everybody know what their odometer is? And I remember not last year, the year before I was teaching this course. Is that how you say that word? One of the students said, odometer? I always thought it was odometer. It's like, no, it's odometer, I think. Pretty sure that's how you pronounce it. What is the odometer on your vehicle? Anybody know? It's the little numbers that determine how far your vehicle has traveled, right? So it's the mileage, which is an interesting word that we still use even though it's in kilometers nowadays, not miles. But it's the mileage on your vehicle. It's that little numerical, on some vehicles, I think on most now it's digital, but it used to be like an old clock radio, just little numbers that flip down as you drive along or go on a little wheel as you drive along. And it can keep track of your distance. Like for example, if my odometer read this, and then I drive for a while, and now my odometer reads that, how far did I drive? Well, ignore the leading 0, and it's the second number minus the first number. So it's final minus initial. So you can figure out how far you've driven. And in this case, 776.9 kilometers. Okay? Some of this stuff I'm sure they covered in driver's ed, right? How to read your odometer, how to figure out your fuel economy. Did they talk about that in driver's ed? No? Okay, they used to. All right, example 3. Which car has the best fuel economy? Well, the winner is car B, because you want the lowest number. Best is equal to smallest number of liters needed to travel 100 kilometers. And I don't necessarily mean to always kind of try to steer this course into political thinking, but you know, there is a significant amount of our country, tends to be in the province 2 to the left, that are very much dependent on the natural gas and oil industries for their economy, to the point where, I mean, they've been so successful, they've been so well off as a province financially that they don't even have a provincial sales tax. They haven't needed it. And now the tables are starting to turn, right? Gas is very expensive to the consumer right now because they are trying to squeeze every bit of profit they can out of it. They know times are changing. They know that the world is going to switch to electric vehicles fairly soon. There will always be a place, I think, in my lifetime for sure, and probably in your lifetime as well, for some gas-powered vehicles. I don't see us having electric-powered airplanes anytime soon. Very large trucks, you know, like semi-trucks, big delivery trucks. There is some advantages. Gasoline is an amazing substance. I made this argument the other day just to try to convince you. I'm not trying to steer you towards that type of thinking that these communists with their electric cars. No. It's a very good thing that we're switching away from gas-powered vehicles. I will argue that. I definitely lean left on this issue. gas-powered cars to get you to and from work, to get you to and from school, to drive around on a Saturday night with your date, those are bad things and they need to go away. But we've built this amazing civilization on gasoline because it's amazing stuff. I made this point yesterday, and some people seem kind of shocked by it. This, I'm actually holding up my SodaStream bottle, for those of you watching this on video, or for you can probably see this, hello. That's about a liter. Okay, how big is a car? Let's say it's a, I don't know, half-ton truck, half a ton. That would be probably the higher end, but let's say, there we go, the 8. 8 of these bottles, and I can move a half a ton 100 kilometers. Think about just how efficient that is. If all I gave you was 8 bottles of a liquid to drink, could you walk 100 kilometers if that was your only sustenance? Maybe. I don't know. You'd be pretty hungry by the end. But there you go. Think about how efficient gasoline is. It's amazing stuff. But it's killing us all. So we got to get rid of it. Anyway, just a little aside. Let's get back to calculating. A car with a full tank of gas traveled 572 kilometers before stopping at a gas station. If the car requires 41.2 liters of gas to fill the tank, find the fuel economy and the cost of the fuel. So it's asking for 2 calculations. All right, which one do we want to do first? Let's do the fuel economy first. So fuel economy is how many liters you drive per every 100 kilometers. Okay, look at this number. If you drove exactly 500 kilometers, how many 100 kilometers is that? And most people have no problem with that. They go, oh, what's 5? Get it? 500 kilometers. So the answer is 5. But then as soon as you put 10s and 1s on it, they freak out. It's like 572 kilometers. How many 100 kilometers is that? 572 kilometers equals how many groups of 100 kilometers? And the answer is, anybody? Again, hint, 500 kilometers is equal to 500 kilometers. So 572 kilometers is 5.72. Yeah, that should not be a tough calculation, but it's something people always have a hard time with. So I changed 572 kilometers to 5.72 hundred kilometers. And the number of liters that I just used was 41.2. Yeah, grab a tissue there. And remember, this isn't really part of this number. This is my unit that I'm working in. And so my final answer here is going to be round to 1 decimal place. It's like, don't we always round to 2 decimal places? Yeah, but you saw that sticker. In this industry, they only use 1. 7.2 liters per 100 kilometers. So I'll say again, round to 1 decimal. And unlike that sticker, we'll actually round like we know how we're rounding. Like we're not trying to fool anybody. So there we go. Get it? Liters per 100 kilometers. Okay, just pause the video here real quick. Oops. Ooh, I accidentally started the virtual camera. There we go, we're back. All right, oh, and we're not done this example. I'm sorry, I forgot. They asked us 2 things. So that's the fuel economy. The other thing is just how much does fuel cost? So, 572 kilometers, that's 200 and something kilometers there, 200 and something kilometers back. That's like a nice day trip to Brandon or something here, driving from Winnipeg. How much should that cost you? Well, let's see. 133.9. Ooh, that's Northern Ontario prices for gas. That's rough. So 133.9 cents per liter times 41.2 liters cancels my liters. So there we go. Now I'm in cents. I don't want to be in cents. I want to be in dollars. So do I divide by 100 or do I times by 100? I divide by 100. Or think of it as I times by the unit of $1 per 100 cents. So cents on the top, cents on the bottom. If back in grade 10 or 11 you learned how to think in terms of unit ratios, unit multipliers, all this conversion stuff is super easy. It really is very logical when you think this way. And there we go. So times those together and divide by 100. When you do that, you get $55.17. And that's about right. Yeah, a 500 and something kilometer trip, that's about a $60 day on the road. And of course, if you'd have goofed it up, if you'd have accidentally times by 100 instead of divided by 100, hopefully you'd have recognized that your answer was goofy. Right? It doesn't cost $55,000 to drive for a day yet. That seems extreme, right? Your answer should make sense when you do it. All right, any questions? Been rattling along here. Everything good for example 4? Example, okay, all right. Let's move on to example 5. Gina traveled a total of 350 kilometers in the city and 200 kilometers on the highway during 1 week of driving. So her car's fuel economy, that sticker, says that she gets 10.5 liters per 100 kilometers in the city, 7.4 liters per 100 kilometers on the highway. Again, it is more efficient using fuel on the highway. But calculate the number of liters of fuel she uses and the cost of the fuel. Okay, so let's do the first one first. Number of liters of fuel she uses. Okay, so she drives 350, we'll do the city first. City. So she drives 350 kilometers in the city. And she has a fuel economy of 10.5 liters per 100 kilometers. So I need to change this number into how many 100 kilometers it is. So I divide by 100. If you just know how to do that really quick, you just say, instead of 350, I'll just turn that into 3.5. Get it? 3.5 100 kilometers. And then, of course, I'm timesing that by 10.5 liters per every 100 kilometers. So the kilometers cancel. And I have 36.75 liters. All right, now let's do the highway one. Highway. On the highway, she drove 200 kilometers. And again, that's 200 kilometers times 10, no, sorry, it's not 10.5 for this one. For this one, it's 7.4. That's it, 7.4 liters for every 100 kilometers. Kilometers cancel. And I am looking at 2 times 7.4. I don't need the calculator for that. That should be 14.8 liters, right? Because kilometers canceled. It's now in liters. So I guess I need a total. Total amount of liters of gas used. Let's see. So that's 36.75. 36.75 plus 14.8 and 51.55 liters. So there, that answered number of liters of fuel she used. Now, cost of the fuel, right? It's the same cost of the fuel whether you're driving on the highway or in the city, so get a total number. And then my cost, well, let's see, I cost 51.55 liters. And what was fuel again? Oh, this time they put it in dollars just to make it different. So it's already in dollars. I don't have to convert it from cents. 1.219 dollars per every liter. Liters on top, liters on the bottom cancel. And I get 62. Now, round this, it's money, right? So it's 62.839. So that rounds to $62.84. And there we go. Okay, that's it for examples, but there's a couple things I want to show you before we let you work on the questions. Okay, let me go to the blog and show you these neat little links I found. Okay, so to the blog. Okay, so first of all, actually, oh, this is the only one I'm going to show you today. It's this government website, and this government website by Natural Resources Canada, again, the same department that forces people who make appliances and vehicles to put that sticker out that says how much it's going to consume. Again, later this week, I'm going to be handing out to you your project for this unit, which will be our hand-in assignment for this unit. It's not really a big project, but again, it comes down to you picking a car, and we're going to figure out everything in terms of how much it costs you to buy it, lease it, monthly payments, and we'll do fuel consumption as well. So I'll use my own vehicle. I am going to pick a 2015. It's a, look at this, you can actually compare gas to electric. We'll do that in a minute, but I'll do my vehicle first. So it's a conventional or a hybrid vehicle, so it's conventional. And it's a, let's see, I have a sport utility vehicle, and mine is a Toyota. And I have the RAV4 XLE one, all-wheel drive LE, that's me. Okay, and search. It should tell me, there it is. I expect 8.7 liters per 100 kilometers in the city, 6.9 in the highway, combined, which is again just the average. And assuming I drive 20,000 kilometers a year, I expect this to cost me that much in fuel every year. So you'll get to do this with whatever vehicle you pick. Question? The date's wrong? Oh, didn't I change the date? Oh, then when I did it, it decided to click and change. There we go. Thank you. Where are we? Let me do that again. Sport utility. 2015 Toyota 4Runner RAV4. There we go. RAV4 L. Mine's an LE. Okay. See if that changes things. See if this is a little better or a little worse. It's a little worse. A little more in the city. Highway's about the same. Combined is 8.9. And there we go. So I expect, oh, a little more. Expect $2,225 if I drive 20,000 kilometers. So there we go. You're going to get to do this with whatever vehicle you choose. Just for fun, let's go back. Go back. And you can compare to other models. Let's clear everything. What if you did decide to invest in an electric vehicle, just for fun? I've always liked those Tesla S's. I think those look pretty smart. And I've always wanted to try driving one. I had a chance to drive the older Tesla. I haven't tried an S one yet. Super quiet, really neat. But all right, battery electric. Pretty sure they run on battery. Yeah, they're battery electric, aren't they? Let's just go all electrics. There we go, all electric, just in case I'm wrong. And let's buy a new, well, last year's. Who am I kidding? I'm never going to buy a new vehicle again in my life. What was that rule that we saw in the video? To avoid as much of the depreciation as possible, 5 years. So let's go 5 years. So it's 2021. So let's get ourselves a 2016 Tesla S Series. I don't know quite what the difference between those two things is, so I'll just pick the one that I'm fairly familiar with, the Model S. The 75 kilowatt hour, that's the bigger one that has, I think, a back seat with passenger sides and stuff. So I'll take the bigger one. And let's see what the search is. Now let's see what it does. Now it's obviously not going to give me liters of gas consumed, but what it's giving me is L/E. So in other words, it's comparing electricity usage as if you had to burn liters of gas to generate that electricity. And look at how much smaller the numbers are, because these are much more efficient ways. And look at how much less it costs me a year. So now start factoring that in to the fact that, okay, a Tesla is a fairly expensive vehicle compared to, you know, even a Toyota Camry or something. But is it, in terms of payments per year, what, $1,500 cheaper? Because if it isn't, then the Tesla pays for itself in the fact that you're not putting gas on it. This is another thing that's interesting. It tells you the range. So 400 kilometers on a charge, I would assume that means, before you'd have to recharge it again. So anyway, if anybody does want to explore electric vehicles, I mean, they're not free, right? Electricity, people think, oh, I'll get an electric vehicle, I'll never have to pay for gas. Well, don't forget, electricity's not free. You do pay an electric bill. So here we go, $554 for 20,000 kilometers of driving. Interesting. Okay, that's about all I wanted to show you. So here is let's go back to the blog. Here's the assignment for this section. We're not going to do all of assignment 4. Number 1's kind of a drag, and you don't even have to do all of number 2. And we'll skip number 6. So there's your assignment. Okay, let me stop the video. Don't need to record this anymore.